Okay, let's begin with question number 7. Move this question to whiteboard, please. Differentiate x sine x with respect to x. We need to use the UV formula. So we call it the UV formula, where if y is given as the function of x with respect to u and v are functions of x, then dy dx can be computed as u dv dx plus v du dx. So a clever selection of u and v is necessary. Like in this case, it's quite obvious. So we have y equals to given as x sine x. So it's quite natural to take the u as, let's say, x, and the v as sine x upon this definition. So du dx equals to 1. And then dv dx equals to, differentiate sine is cos x. All right. So now we use this formula to get dy dx. Ta-da. So dy dx equals to is u or x, dv dx is cos x, plus v is sin x, du dx is 1. So you need to write the 1. So this is the answer. That's it. You just leave it in this form. Please take note. For the first part. For the second part, how we continue on this, hence evaluate the stages. If you notice carefully, their questions will be linked, even if they don't mention. So you notice that part here that we need to integrate is within that. This means that, please take note. So integration. So before we do the integration, you may want to rewrite this as this first. So x cos x, making that the subject of the matter now, is equals to dy dx, but that the y, I'm just going to substitute back as this thing. So dy, okay, I'm going to write dy dx first. I'm confused on that writing. Cancel minus sin x. So when you integrate this, the idea is that when you integrate something in dx, like that, you integrate each other term. It means cos dx equals to integration of dy dx against dx minus integration of sin x dx. But this is a definite integral. That's why I'm not adding any constants. That means 0 to pi over 2. Understood that that is in radians. Please take note. 0 to pi over 2. So on the right hand side, we simplify. dy dx we integrate means we just get y. So the y now evaluated at the limit of, that means the evaluated as numbers pi over 2 to 0. And then when you integrate sine, negative sine x, becomes, because differentiate cos is negative sine. So it becomes plus cos x. In the box, remember the differentiate cos is negative sine. So yeah, that's how we see it. Reverse. So like that. So now it's just a matter of substitution and evaluating it. So the y now in the bracket, we need to change back. That's why I wanted to put the y, but I might do like this also at this step, because the value of x is where it's what is evaluated. So this part, let's say we put cos of pi over 2 minus cos of 0 in radians. This will be like pi over 2 sine pi over 2 minus 0 times sine of 0. Okay, so we write everything up nicely. It becomes cos 0 like that. And then when you evaluate this further, it says pi over 2 sine 90 degrees is 1. Okay, pi over 2 is about 90 degrees radians. This is 90 degrees. So easy to think like that. So I'm doing that. This is 0, this part. Cos of 90 degrees is 0, isn't it? Yep. And then minus cos of 0 is 1. Yep, cos 0 is 1. So that means the answer is nicely just pi over 2 minus 1 if exact. Okay, we didn't mention exact or what. So normally we try to put decimal to some decimal places, correct to some decimal places. So pi over 2. Okay, let's evaluate that, please. So pi over 2 minus 1. This is roughly about 0.571 significant figures of decimal places. Thank you.